Erosion and soil. We know that the process of breaking down rock is called weathering. This process has been going on for millions of years and has changed the shape of the Earth's surface. It's different than it was millions of years ago, or tens of thousands of years ago, or hundred thousands of years ago, because of things such as weathering and erosion. So anything that breaks down rocks or weakens them is considered to be weathering. Some examples of that are burrowing animals into these crevices, moss, plants, oxygen, other things like water, natural acids, plants acids, those type of things. There are two different types of weathering. We have physical or mechanical weathering, and this is when they are broken down by physical means. And some examples of that is ice wedging, abrasion, like wind abrasion, plants, animals. The second type of weathering is chemical weathering, and this is when the chemical makeup of the mineral in the rock has changed. So some agents of that is things like acid rain, water, air, organic things. So let's first talk about mechanical weathering. First, we have agents of mechanical weathering along the side, and you probably do want to know those. Abrasion is things like wind. Frost action, that would be your ice wedging, where you get water in there that's going to freeze and thaw, and as it freezes, it expands and breaks off more pieces inside those cracks and crannies. We have gravity, things like glaciers, things like that are created by gravity, and other things such as mudslides, exfoliation, organic activity. So mechanical weathering is basically a physical process, and the chemical makeup of a rock stays the same, which means essentially the minerals inside are going to stay the same. Sediments that are made from the breaking down of these rocks are sediments that are going to have the same characteristics as the original rock, and we call that original rock parent rock. And don't forget, you need to know that for the test. Some examples of mechanical weathering are growing plants, burrowing animals, and expanding ice. We'll give that a little bit more detail in just a couple minutes. So exactly how does mechanical weathering work? Well, first, how does plants play a role in it? Well, plants can have their roots growing, and they can get in between the cracks and crevices of these um, um, places of rock, and as they grow, they roots expand, and as those roots expand, they break apart some of the pieces in there. Same thing with animals. These little animals like moles and earthworms, etc., will burrow their way into the ground, pushing up sediments, getting them up so they can be weathered, but also into these little cracks and crevices, and getting some of those sediments out of that area. We already talked about ice wedging, and that is when the water goes in and it freezes and then again expands, just like the plant roots, and it can break up that. One thing that happens when we have weathering, we have sediments that are produced from this weathering. And just like in our lab that we did the other day with the antacids, the one in the tablet and the one that was crushed up and we put in the water, when you have small sediments like the small pieces of that antacid, what you can get is you can get more surface area for this weathering to occur at, or for both chemical and mechanical weathering to occur at, because we have smaller pieces with surface area all the way around. So let's talk a little bit about chemical weathering now. Chemical weathering usually occurs more near the surface because usually it is exposure to something. So to be closer to the surface is usually how it works. Chemical reactions can dissolve or change the minerals in the rock, and this usually changes the chemical composition of the rock, which can weaken the rock, make it more susceptible to weathering in general. Some agents are natural acids, plant acids, pH of soil, and oxygen. We're going to talk about those in a little more depth here when we talk about how chemical weathering works. First of all, natural acids are made, when we have water and carbon dioxide come together, there is an acid that is created called carbonic acid. And this will break down calcite found in the limestone. This is how caves are formed, actually. And when we did our interactive on weathering, and we did our very first scene there, had a big piece of limestone, and you pressed on the water agent, and that rain mixed with the carbon dioxide created carbonic acid, and it created a cave from that. Feldspar, which is a mineral, can be broke down into clay. So these are different types of sediments that can be broke down that can change the Earth's surface, can create certain types of sediment, which can create parts of soil. The second type of acid are plant acids, and this acid is given off as decaying plants die, as they're on the ground as litter, plants and sticks and stems and all those things that come off the tree as they start to decay and go back into the ground, they give off acids, which can cause chemical weathering. Also, the pH of the soil or of the area is really important because most minerals are much more soluble in acidic soil. Now, remember, acidic soil is soil that has a pH lower than 7. pH is greater than 7 are basic. So, if they're more soluble, they're going to be able to dissolve in that more, therefore be much more susceptible to changing its chemical makeup, plus being eroded away much easier. Next is exposure to oxygen. We call that oxidation. And for oxidation to occur, just like if you remember from our last test, you have to have some type of iron or metal, you need to have water, and you need to have air. So an example of that is magnite. It has iron in it. It can react with water and oxygen and form a little bit of a rust material, like rust-like material on it. So that is what oxidation is, and that is a definite example of a chemical weathering. There are two things that can affect the rate of weathering and the weight of weathering, and that is the climate and the rock type. We know that there are two major things that we look into for climate, and that's temperature and moisture or precipitation in that area. And it's the temperature, the precipitation over a long period of time for a region, not just a day-to-day. So soil temperature and moisture affects the rate, of both chemical and mechanical weathering. Chemical weathering is more rapid in warm and wet climates. Also, the rock type can affect rate of weathering. So if you think about different types of rocks, they can weather differently in different climates. And also, think about the difference between igneous rock and a metamorphic rock, and which one of those do you think would weather more easily? The metamorphic rock that is tightly compacted, smooth-edged, and made with lots of heat and pressure, or your igneous rock that actually has pores in it, kind of brushes off in your hands, that type of thing. When these sediments are broken down into rocks, they produce, or what starts to form, our soil. Soil, as we remember, is a mixture of weathered rock, decayed organic matter, mineral fragments, water, and air. And if you look at this picture here, it is primarily made up of mineral particles, 45% of it. Small amount is the organic matter, which is interesting. We'll talk about that in a minute. It can take thousands of years to make soil, and the thickness of your soil can be from a few centimeters to about 60 meters. So what are the 5 factors that can affect soil formation? Number 1 is the climate. We talked about that. That also affects the weathering of rocks, etc., the types of rocks that are there. The slope of the land, the more steep it is, the more open it is to things like erosion and that type of thing. The types of rocks used, types of vegetation, and the amount of time weathering. So what is soil made up of? We already said that soil was rocks and minerals, organic matter, and air and water. So let's talk about it. First of all, rocks and mineral fragments is what makes is part of soil. So the weathered rocks produces these sediments such as clay, silt, and sand, and they come together to make the soil. Next is organic matter. Plant leaves, stems, roots, animals, and microorganisms start to decay, and they make this really dark, nutrient-rich soil called humus. However, you have to remember that's not the only thing that we want in good soil. Good soil is an equal amount of that rich dark humus and weathered rock material. Also, soil is made up of water and air, so we need to have a water infiltration, an area where water can soak into the pores of your soil. If we take a cross section of soil, we call that our profile. And so if we looked at the layers of the soil, and remember we call the layers of soil horizons, there are horizon A, B, C, and then bedrock. Those are the different parts. Horizon A being the top, horizon B being the subsoil, and horizon C being the bottom layer. Horizon A, the top layer, is usually covered with litter, which is a good thing. Leaves, twigs, cones, pine cones, things like that, because it helps prevent erosion. As wind comes through to erode things away, it will blow that litter away before it will the soil that's needed. Humus is here, and it's dark and full of nutrients, and it's also dark, which means it absorbs solar energy. So it absorbs the energy that is needed and the heat that is needed from the sun for plants to grow. Horizon B has less organic matter and is used primarily for leaching the acids created in Horizon A. Remember, we want to keep that pH level at a certain level so that everything is in homeostasis. Horizon C is partially weathered rock and is the parent rock of the soil. So you need to know that for the test, that it is the parent rock of the soil. There are 4 major classes of soil. Remember, when you pick up soil, it will naturally clump together, and those natural clumps are called beds. Now, why is the different classes of soil important? It's because of how they're packed together. And this will affect their pore space, which will affect how water filters through, how roots can get through the different areas, little animals and things like that. So there's 4 types: platy, blocky, granular, and prismatic. It's important that you understand that how those are put together are going to affect how that soil is made and how things penetrate it. Climate and parent rock affect soil. Again, the climate can affect the type of soil because temperature and moisture can affect that soil. Different soil, you can have different soil in deserts than you do in Arctic areas. And we'll talk about that in a minute. The soil pH helps control the chemical reactions and the organisms that can live in that soil. Also, time will affect the soil. The more weathering that occurs and the longer it takes, the less those sediments are like its parent rock. So this isn't the best picture, but I really want you to see this picture because if you look at the bottom left picture in the desert there, look at the soil there. You don't have a lot of humus there, and notice the roots are growing straight down to get water. It's going straight in. If you look up here and the top right, the farthest, the one in the middle, this is from the Midwest, you see that you have humus that's up there. And that humus is dark and full of nutrients, and even below it, it is kind of darker than what you would see in the desert soil. And look at how those roots are growing. They're growing outward and downward because it can get those nutrients from all those areas where the desert's going straight down. So what are some causes of soil erosion where erosion gets washed away? Well, water flow and wind are big causes of erosion that really change the surface of the earth and has over millions of years. The more steep slopes are and the less vegetation on it is going to cause more erosion because there's nothing there to stop the water from flowing. Wind over the Earth's surface picks things up, sediments, and it moves them around. Third thing that can cause erosion is human interaction. Usually soil forms at the same rate as erosion occurs, which kind of keeps this in balance. But we can get an imbalance occur because of things that we humans do, such as chopping down the rainforest. We chop down the rainforest, And what happens is that canopy above that helps protect that just couple centimeters of soil below is wiped away. And that canopy also protects all the litter that is on top of that soil. So the wind can come and just easily push it, blow it away, and then you only have a couple centimeters of soil left that can very easily be washed or blown away. So what's the effects of soil erosion? First, we have a very big agricultural cultivation effect. You know, the nutrient balance can become negative due to erosion. Things can be wiped away that are needed for plants to grow. And we can have fertilizer that we may add into these that also get washed away that then end up somewhere else that causes an imbalance there. So for example, when we put fertilizer on our crops in this area and then the heavy rains come and the ground gets into the groundwater that then eventually gets into Lake Erie, and that extra fertilizer gets in there and it creates algae blooms. So you know, erosion carries these sediments and these things away, but then they have to be deposited somewhere that can then cause trouble in those places. And that goes along with the excess sediment that is also on this slide here. Forest harvesting. When forests are removed, soil is exposed and erosion can occur. And I just talked about that with the tropical forest because, you know, it's really important there because the soil, the fertile soil is only a few centimeters deep. Actually, and then again, overgrazing. We can have these grassy areas and we put all these animals in there to graze this area, and then it becomes less vegetative, therefore being more susceptible to erosion. So what can we do to prevent erosion? And a lot of these things we talked about with our vocab words from last week. We can manage crops, no-till farming. We can build tree shelter blocks. We can block the wind from building these by building tree shelters up. Grazing instead of plowing under crops. So don't plow them under, you know, leave them up all year and let the animals graze on them. And it will help with the overgrazing also. Reduce erosion on slopes by contour farming. We talked about that with our vocab. Terrace farming. You build the terraces into the side of the mountain. And reduce erosion of exposed soil. You know, you're going to reclaim the land. You want to control the water flow. Keep exposed areas slightly moist so that way everything's not real loose and can just be swished away. Now, another agent of erosion are glaciers. Glaciers are formed in areas where there's a lot of snow, and they're formed primarily because of gravity. You know, you get all this snow that's compacted on each other and stays on each other years after years after years after years, and the gravity, the force of the gravity and the weight on that causes the bottom layers to become ice, which then causes the glaciers to start slowly moving. And these pile up until those lower levels become ice, and the weight of it causes it to move. As glaciers move slowly over things, it picks things up and it erodes the land underneath it and it deposits them elsewhere. So you have a lot of erosion and deposition going on, changing large areas of the Earth's surface. This happened here in this part of the country, in the Midwest. This is how the Great Lakes were formed. We had a glacier come down along this area and it dug out and carved the Great Lakes. And as the glacier retreated, these Great Lakes were left behind. Just a wonderful economic resource, as did it leave different areas of rock and formations that were able to then have our gas wells and things like that. Plucking is a phenomenon associated with glaciers that is referred to as when moving glaciers pick up loosened rock and materials. They pluck them up. And what they do is they then transport these plucked up materials, and they take these rocks and fragments and they carry them with them. And as they're slowly moving, and all of these are pressed down on top of with lots of pressure, they gouge out and they scrape the rock layers below them. The deep gouges are called grooves, and The shallower marks are called striations. And in this area of the country, because we've had glaciers here, we can find lots of these grooves and striations along the lake shore. We have beautiful examples of them at Kelly's Island, but you can also find these things right here in Ohio, right along the Great Lakes. Ice depositing sediment. So this is glaciers move, and then the sediment is dropped as glaciers melt. So the till is different size sediment that's left behind as a sheet of sediment. Moraine deposits is a ridge of material that piles up as the glacier stops to move. At the edge of it, it starts to pile up all of this debris. Outwash deposits is when it starts to melt, and you get what's called meltwater. It has lots of material in it, and that outwash comes out with the water and the material in it. This meltwater can eventually form a river, and we call that an estuary. These pictures here are great examples of what each one of these looks like. So glaciers is a very important agent of erosion that has really transformed the surface of our earth in profound ways. So glaciers are important because of the immense effect that it has had on the Earth's surface, as I just talked about, and how it's deposit economically important resources to different areas of the world. And like I spoke earlier about Lake Erie and some of the other types of rocks that have been transported here because of glaciers. Well, that wraps up our notes on glaciers for now. So we can end that.